Okay, we are here and we are talking about greatest common factor and least common multiple, which we can abbreviate to GCF and LCM. And I have to admit, sometimes I even get these mixed up, but we'll talk about them here and talk about why they're useful, and that'll help you to remember them, okay?
Okay.
Okay, so first let's define greatest common factor. It's the greatest integer that can divide into two or more integers. So, that sounds kind of complicated. Let's go ahead and look at an example because it'll be clearer. So, if we want to find the greatest common factor of 32 and 48, so a factor is an integer that can divide into a number. So, there's lots of factors of 32, like 2 is a factor of 32 and 8 is a factor of 32, and there's lots of factors of 48. But we want to find the one that's common to both of them, that's the greatest. Okay? So first what we can do is we can list all the factors for both of them. Okay, and I've started the list here. So we'll list the factors of 32. So one factor, and remember a factor is a number that can multiply by another number to get your product. So here the product is 32. And so you can multiply 1 times 32 to get 32, right?
Yeah.
Okay, so I've started this next row. You can multiply 2 by something to get 32. Do you know what it would be?
16.
Good, so let's write that in. And then there's another couple of numbers that can multiply to get to 32. Do you know what they could be?
4.
4, good. And 4
8.
times what? 8. Good, good. And when you create factor tables like this, you can kind of go up in numbers here. You can say 1, 2, then you could ask yourself, does 3 go into 33? No, it doesn't. Then you get to 4, and you say, oh yeah, 4 times 8. Then you get to 5, you say no. 6, you say no. 7, you say no. And then all of a sudden you're back at the number that's here, so then you know you've covered everything.
Okay.
Okay? So now let's do the same thing with factors of 48. So let's start with the 1. And then what is 1 times what equals 48? A little bit
48.
easy. Good. Okay. Now, let's go to 2. 2 times what is 48?
24.
24. Good. All right. What would be next in this on the left-hand side? 1, 2. What would we try next in our heads?
3.
3. Okay. And actually 3 goes into 48. And can I teach you a trick on how to know that something's divisible by 3?
Sure.
Add up the digits. Here it's 4 plus 8. What's 4 plus 8?
12.
And then if that number, 12, is divisible by 3, then this number is divisible by 3. It's always a check. So you know this is divisible by 3. 3 times what would equal 48? Can you think of what that might be?
8? Oh, no, not 8. Sorry.
3 times 8 is 24. That's half of
So
40.
16 then.
So 16, yeah. Good. Now, what would be next on the left-hand side?
Well, we would try 4.
Okay. And do you think 4 might go into 48 if you do a little mental math?
Yeah.
How many times?
12.
Good. And then what would we try next?
Well, we tried 5, but that couldn't work, so 6.
So 6. And does 6 go into 48?
Yeah.
Okay. And how many times?
8 times.
8 times. Good. And then you would try 7, and you would say, well, 7 doesn't go into 48, and then you'd be back up here at 8, and so you know you're done with the factor table. Make sense?
Yeah.
Okay, good. So now we have all of the factors of 32 and all of the factors of 48, and we want to find the greatest common factor. So one common factor they both have is 1. Okay, a common factor means it's in both tables. They also have 2, but those aren't the greatest common factor. So what's the greatest common factor for 32 and 48?
4.
Okay, it could be 4, right? But do you see any other numbers that are even greater than 4 that are in both tables?
Yeah. 16.
16, that's right. That's the greatest common factor, okay? So what we've done is we find the greatest factor that is common to both lists, and that's what greatest common factor means. And so we figured out that that's 16. Now, why should you care? What does this even matter? Well, there's a couple of good reasons with greatest common factor. There are others than these, but here are a couple. So one is with simplifying fractions. So let's pretend that you actually had a fraction that was these two numbers, 32 and 48. You had 32 over 48. You said, hey, I want to simplify that fraction. I think I can simplify it. And then you said to yourself, oh, well, 2 goes into 32 and 48, so let's divide both by 2. And then you get to 16 over 24. Does that make sense?
Yeah.
But then you say to yourself, well, wait a second, that can simplify also, so I'll divide both of those by 2. And then you get 8 over 12. Following me?
Yeah.
And then you say, wait a second, those can both be divided by 2. So you simplify that even further to 4 over 6. And then you say, wait a second, and do it even one more time. That's a lot of steps, right?
Yeah.
You don't want to go through those steps, first of all, because it just takes too much time. But also, with each step, you might make a mistake. So what you really want to do is do only one division, one time. And you want to find, instead of dividing these both by 2, you want to divide them by their greatest common factor. And that way you can get rid of all of those steps in the middle and just say 32 divided by 16 is 2, and 48 divided by 16, the greatest common factor, is 3, and you get right to 2/3 right away. Easier, right?
Yeah.
Okay, good. Another reason why is to factor expressions. You'll get into this a little bit more later, but if you have this expression, 32 plus 48, then you can factor out the 16 outside of these parentheses, and then you could have 2 plus 3, kind of like the 2 and the 3 and the 2/3 here. And this will become more important when you do algebra and have variables like x and y and things like that.
Okay.
Okay, so that's greatest common factor. Now let's really quickly go through least common multiple. It's in some ways it's almost the opposite. It's the least integer that is a multiple of 2 or more integers. So let's take a look at an example. We want to find the least common multiple of 3 and 4. Now, the multiples of 3 are like 3, 6, 9, 12. It's things that 3 multiplies by in order to create a greater number that's a product, okay?
Okay.
So let's list all the multiples of each one of the numbers. So the multiples of 3 is 3, 6, 9, 12. And the multiples of 4 are 4, 8, and 12. And we list them up to the point where it's 3 times 4, the one number by the other, because we know that 12 is at least a common multiple of them. Because they're multiplying by each other. Okay, so then we've listed that, and then we find the least number that's common to both. So what's the least number that's in both of these lists?
12.
Yep, that's right. The least common multiple of 3 and 4 is 12. So you might say, well, that's easy. Why don't you just multiply? Why do you have to write out this whole list and everything? And the reason why is because sometimes it's going to be a lower number than the two numbers multiplied by one another. So let's do another example here. What's the least common multiple of 14 and 28? Well, you could multiply 14 times 28, but that would even be hard for mental math for me. It'd take me a little bit of time. But as soon as you start making the list, you can see multiples of 14 are 14 and 28. And you're like, wait a second, of course, the multiples of 28 include 28. So what's the least, we don't even have to list out all of the multiples. What's the least common multiple of 14 and 28?
28.
That's right. So we can go ahead and circle that there. Now, why should you care on this one? Well, this is really useful to find the least common multiple when you're adding fractions. So let's say you had 1/14 plus 1/28. Here's our two numbers, but I've made a fraction here, a sum of two fractions. Well, you could say, okay, I need a common denominator, so let's multiply 14 by 28. Well, gosh, that would be a lot of work to multiply 14 by 28, and then after you added them up, you'd have to simplify your fraction. Instead, you want, for your common denominator, you want the least common multiple. So this fraction here, the second one, already has the denominator as the least common multiple. We just want to change this one to be a fraction that's equivalent but has 28 in the denominator. So what would we multiply 14 by to get 28?
2.
And so we multiply the 1 by 2 also, and then we've turned this same problem into this. The 1/14 is the same as 2/28, and then 1/28 is the same. So when you add those two together, what do you get?
3/28.
3/28. And that is so much easier than multiplying 14 times 28 and doing a whole bunch of arithmetic, right?
Yeah.
Okay, good. So just to review, Greatest common factor, really useful for simplifying fractions. Least common multiple, really useful for adding fractions. But in both cases, you make a list of the factors or list of the multiples, and you find either the greatest common one or the least common one. Make sense?
Yeah.
Great job.